Hi, this lesson is about the slope of a line. So we're going to define what the slope of a line is. We'll learn how to compute the slope of a line and learn a new formula and use the slope of a line to graph a line. So the slope of a line is the measurement of the slant or inclination of a line. So when a line is in the format of y equals mx plus b, we call this format the slope-intercept form of the line because the m, the number in front of the x, is called the slope, and the point 0b, which comes from this value right here, there's the b, is considered to be the y-intercept. The sign of the slope, meaning whether it's positive or negative, zero or undefined, will determine the direction of the graph of the line. So this table here gives us a summary of what to expect. So when your slope is positive, m is greater than 0, you can write the equation in slope-intercept form, y equals mx plus b. That means that the direction of the line, that means it will be increasing or increases from left to right, and the graph will look something like what you see here on the right. When your slope is negative, so something less than 0, you can also write it in the format of y equals mx plus b. The direction of the line is that it decreases from left to right, and the graph would look something like what you see here. When your slope is equal to 0, when your slope is 0, the equation of the line is going to be y equals b. That will be a horizontal line, and horizontal lines go from left to right, and they're flat. And then finally, it's possible for your slope to be undefined. When your slope is undefined, the equation of the line is written as x equal to a, where a is some number. That will be a vertical line, and vertical lines look like this. They go up and down. There's no slant associated with it. All right, so using what we just discussed, we're going to identify the slope and the y-intercept for each of the following lines. So the first one here in blue says y equals 3x plus 1. Your m is the slope, and m is the coefficient of x. So m is 3. My b is the constant that's after the x term. So b is 1. Therefore, my y-intercept is the point 0, 1. So if we look here at this dark pink color, we have y equals negative 2/5, so I forgot my variable, negative 2/5 x minus 3. There, my slope is negative 2/5, so that's your m, and your b is negative 3, so therefore the y-intercept is the coordinate 0, negative 3. So your y-intercept will always have the first coordinate of 0, and the second coordinate will be b, which is found here in the equation. Okay, our third example is here below. This equation is not in slope-intercept form. It's in what we call a general form. So I have 4x minus 8y equals 3. So here I cannot pick out what my slope is until I put it in slope-intercept form. That means we need to solve it for y. We want y on one side of the equation and everything else on the other. So that's what we're doing here below. First, we subtract 4x to both sides. So I have negative 8y equals negative 4x plus 3. Then divide both sides by negative 8, which you see here. And when you simplify, you get that y is equal to 1/2 x minus 3/8. So 1/2 comes from simplifying negative 4 over negative 8. So the two negatives make it positive. When you reduce it, that's where the 1/2 comes from. So my m, or my slope, is 1/2. My b is negative 3/8, and therefore the y-intercept is 0, negative 3/8. All right, so now that we know how to pick out the slope and the y-intercept, let's learn how to actually compute the slope. So we can calculate the slope of a line if you know 2 points on that line. And suppose we call our 2 points point 1, p sub 1 is x sub 1, y sub 1, And point 2, which I'm calling p sub 2, is x sub 2, y sub 2. So the formula to calculate slope is that m is equal to the difference in your two y coordinates. So I'm stating that as y sub 2 minus y sub 1 divided by the difference in your x coordinates. So that's x sub 2 minus x sub 1. An abbreviation for what we just wrote here is what you see here on the right. This is read as change in y, divided by change in x. So that little triangle you see instead of the y, this means change in. It's a Greek letter called delta. This is called delta. So that's a Greek letter, and that means the difference in something. So change means the change in something means the difference in something. So delta y and delta x means the change in y, or the difference in the y values divided by the difference in the x values. Okay, so that's a formula that you would want to memorize. It's useful in this course as well as future math classes. So here we'll practice using that formula. We want to calculate the slope for each of the following examples. So the first one here in green is that point 1 is negative 3, positive 5, and point 2 is positive 4, 0. So my slope calculation is below. I'm going to do the change in y. So I'm taking the two y values, 0 minus 5, that's what you see here on top, divided by the difference in the x value, so it's 4 minus negative 3. So that's what you see here below. So when you simplify all that, you end up with negative 5 in the numerator and positive 7 in the denominator, because 4 minus negative 3 is 7. So your slope is negative 5/7. So to illustrate it, exactly what the slope is telling you here, it's negative. So as I mentioned before, negative slope means that your line is going downward from left to right, which is what you see here. When you plot the 2 points, here's the point negative 3, positive 5, and here's the point 4, 0. So the difference in your y values is this change in y. That's what we call the rise of the slope, and the change in x, that's what we call the run. So another abbreviation for stating the formula of slope, it's rise over run. Means the same thing as delta y over delta x. So that might be another way that you might help you remember it. And it's really just measuring how slanted the line is. Okay, here's another example here in blue. I have that my first point is positive 4, negative 1, and my second point is negative 2, negative 5. Okay, so when we subtract our y values, I have negative 5 minus negative 1 divided by the difference in my x values, which is negative 2 minus 4. So when you simplify, I get negative 5 plus 1 in the numerator. I still need to subtract my denominator, so that's negative 2 minus 4. And when you subtract the numerator and the denominator, you get negative 4 over negative 6. Now we know that two negatives make a positive, but you can also reduce the 4 and the 6, so your slope is 2/3. So if you were to plot this line using these 2 points, this would be a line that would be going upward from left to right, because my slope, 2/3, is a positive number. All right, so here's another example here in orange. I have that my first point is 0, negative 5. My second point is 3, 0. So you might remember from an earlier lesson that point 1 is the Y-intercept. So these just happen to be two special points on the line. And that point 2 is the X-intercept. Right? Remember, y-intercepts exist when the x value is 0, and x-intercepts exist when the y value is 0. So if I compute my slope, I have 0, so this is the 0 that I'm plugging in on top, minus -5, so that's the numerator, and then divided by the x values, which are 3 minus 0. So when you simplify that, you get that your slope is 5/3. All right, so let's move on. We're going to use the information that we learned so far to graph a line, to graph the following lines by using the slope and the y-intercept. So this is a different approach than the way we graphed lines before. In previous lessons, we graphed lines by picking values of x and plugging them into the equation and then finding values of y. So we set up a chart to keep track of our x and y values, and then we plotted them. But this is a more visual approach where we're not actually going to compute anything. We're just going to identify the slope and use that information along with the y-intercept to graph the line. So that's the first thing we're going to do, is find the slope. So in this equation, my slope is 2 and my y-intercept is 0, -1. So the first thing you want to do is plot the point 0, -1, which is what you see right here. I'm just going to color it in again in black. And then we use our slope to find our second point. Now, using our slope means that you have to consider slope in terms of rise over run. Remember, the top is the rise and the bottom is the run. So if my numerator is 2, that means I'm going to go up 2 units. And if my denominator is 1, that means I'm going to go right 1 unit. And I'm going to go up 2 and right 1 from the y-intercept. So when I go up 2 units, that's what you see here. This is my rise. And then when I go right 1 unit, that's what you see here. This is my run. So I end up at the point 1, 1. So when you connect the 2 points, you get your equation. All right, so let's try another one. Here I have y equals -1/4 x plus 2. Here my slope is -1/4 and my y-intercept is 0, 2. So you start this process by first plotting your y-intercept. So that's the first thing you do, is plot 0, 2. Now I'm using my concept of rise over run. So -1/4. That means that either the negative is on top or on the bottom. We usually consider our negative to be on top of the fraction. So if it's -1 over +4, that means I have to go down 1 unit and I have to go right 4 units from the y-intercept. So here I have my down 1 unit, right? So this is the rise, even though we're going down. It's the vertical movement. And then I go a run right 4 units. This is my run. So I end up at the point 4, 1. Connect the 2 points and you have your graph. All right, one more. In this case, you're given an equation that is not in slope-intercept form. So in order to use the slope and the y-intercept to graph the line, you first have to solve it for y. So first thing we do is add 3x to both sides. And then we multiply both sides or divide both sides by -1 so that we have a positive y instead of a negative y. So our equation in slope-intercept form is y equals -3x minus 2. So my slope is -3 and my y-intercept is 0, -2. First plot this, your y-intercept right here, 0, -2. Now I have to use the concept of slope to get the second point. So remember, here I have -3 as my slope. I need a rise and a run, so I'm writing -3 as a fraction as -3 over 1. So if my numerator is negative, that means I have to go down 3 units, and then I have to go right 1 unit. So that's what I did. From 0, -2, I went down 3 units. So this is what we consider our rise. And then I went over 1 unit. So this is the run. So I end up at the secondary point of 1, negative 5. So now you should try the homework. Good luck.